All right, this is lesson 6.2. We're going to get into properties of parallelograms. Any polygon with four sides is a quadrilateral. However, some quadrilaterals have special properties. They are given their own names. Opposite sides of a quadrilateral do not share a vertex. Opposite angles do not share a side. So a quadrilateral with two pairs of parallel sides is a parallelogram. To write the name of a parallelogram, you can use the symbol for a parallelogram. So if parallelogram ABCD, we know that AB and CD are parallel and BC and DA are parallel. All right, so the first property of a parallelogram, then its opposite sides are congruent. So its opposite sides are parallel, its opposite sides are congruent if it's a parallelogram. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So B and D and A and C are the same. If a parallelogram or if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So A plus B would add up to 180, B plus C would add up to 180. They'd be same side interior angles. And then if it's a parallelogram, then its diagonals bisect each other. So AC and BD would split each other in half there. They would bisect each other. All right. In CDEF, DE is 74 and DG is 31. All right, so DE is 74, DG is 31, and FCD is 42. Find EFC. Well, EFC would be over here. We'd take 180 minus 42, which would be 138. Those would have to add up to 180. On DF, well, DF would be this whole diagonal. We'd double the 31. So that would be 62 because the diagonals are bisected in a parallelogram. And then CF would be 74 because it would be the same as DE because they are opposite sides in a parallelogram. WXYZ is a parallelogram. Find YZ and a measure of angle Z. All right. Well, YZ, since that's a parallelogram, then we can set those equal. 8a minus 4 equals 6a plus 10. 2a equals 14. So a equals 7. Plug it back in. Set 56 minus 4, 52 for YZ. All right, for the angle, those are consecutive angles in a parallelogram, so I want to add those together and set them equal to 180. 18 plus 9 is 27, so 27b. Negative 11 plus 2 minus 9 equals 180. So 27b equals 189. Divide 189 by 27. Gives you 7. Okay? Implying angle Z, 7 times 9 is 63, plus 2 is 65 degrees. So using those properties of parallelograms to answer those questions. EFG is a parallelogram. Find JG. Well, that means that the diagonals bisect each other. So we know that we can set those two equal. So 3W equals W plus 8. 2W equals 8. W equals 4. JG, 4 plus 8 is 12. When you are drawing a figure in the coordinate plane, the name ABCD gives the order of the vertices. So when you're doing these next type of problems, make sure that you put them in order. So J, K, L, we need to find the coordinates of vertex M since this is a parallelogram. Well, if you think about the slope, we know they're parallel. To get from K to L, you go 1, 2, 3, 1, 2, 3, 4 over 1, 2, 3. I can't see that. Up 1, 2, 3, 4 over 1, 2, 3, 4. So from J, we would go up 4, 1, 2, 3, 4 over 4. 1, 2, 3, 4. So right there would be JKLM at 7, negative 4. So figure out your slope and go from there. All right. Make sure you go in order of the vertices. PQRS. All right, so PQRS. Now remember, PQ, so R is going to have to be somewhere up here because we got to go in order. PQRS. So to get from P to Q, we're going to go up 1, 2, 3, 4, 5, 6 over 2, up 1, 2, 3, 4, 5, 6 over 2. So R would be right there at 7, 6. So make sure you go in order of the vertices when you're figuring out problems like that. All right. All right. A little proof here. ABCD is a parallelogram. Prove that AEB is congruent to CED. Well, so we're trying to prove those two congruent, and we know we got a parallelogram. There's a bunch of different ways you could do this. We know that they bisect each other, and then we'd have vertical angles. So you could go side angle side. You could use alternate interior angles, go angle side angle. There's all sorts of different ways to do that. The They decided to use side 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 because opposite sides are the same. There's a bunch of different ways that you can go through that. Okay, let's go through one more parallelogram proof here. We know these are parallelograms. Prove C is equal to G. All right, so we've kind of got our given already. Trying to prove angle C is congruent to G. All right, well, how do we know if they're both parallelograms, A and G are the same, and A and C are the same, right? So A is congruent to G, and A is congruent to C because of given opposite angles of a parallelogram are the same. Then if A is G and A is C, then we could say angle C is angle G.